All right, hello everybody, and thank you for taking part in this Desmos activity. If you are following along, you've now reached the point where you know what an imaginary number is, right? An imaginary number is, let's say, born when you have the square root of a negative number. So you got that square root sign, and there's a negative underneath it. So you learned that those are called imaginary numbers. And when we take an imaginary number and we either add it or subtract it to a real number, we call those numbers complex numbers. Okay, so it says a complex number is any form of, is the number is any number in the form of a plus bi, where a and b are real numbers, such that b is not equal to zero. So if you had b equal to zero, well, then it's 0 times I. It's just a real number now because there's no imaginary part to that number. So what we're going to do is we're going to add, we're going to subtract, and we're going to multiply these numbers just like we did with polynomials. And you're going to find that it's kind of like just combining like terms. So in this first example, and just by the way, we are on page 25 right now. And if I take a look at example 1, I've got 4 minus 3i plus 4 plus 3i. So what I want to do is I want to treat these real numbers and these imaginary numbers just like I would treat variables or like terms. So I'm going to group the 4 and the 4 over here, and they are being added as evidenced by the plus sign there. So that's why I'm just going to keep their signs. And then I have minus 3i plus a positive 3i. And when we combine the negative 3i plus 3i, we're actually going to see that that turns to 0, and the 4 plus 4 turns into 8. So we have 8 plus 0, or just an answer of 8. And you can see that our imaginary part actually eliminated itself, or both of them combined to eliminate. So we ended up with just a real number in example 1. In example 2, you're going to want to apply that subtraction sign similarly to how you would apply a negative coefficient. So I'm going to write the first expression just how I see it, and then we're going to have minus a negative 2 minus 4i. And when I see that minus a negative, I'm going to change that to a positive, and I'll group it with the other real number over there. So that negative 2 or minus negative 2 turns into plus 2, and then we have minus 3i minus 4i. Combining the real parts, I get the number 7, and combining the imaginary parts, I get minus 7i. And that would be my final answer. So as you can see, it's really just like combining like terms like you would with x, x squared, something like that. So the one thing that I want to make sure that we are always careful of here is that we're writing our answer in the form of a plus bi. And that's just standard form for a complex number. So when we had a standard form of a polynomial, we wrote all the terms in order of their power of x or their degree. So we always had that cascading x cubed, x squared, linear, constant. So here, we're always going to write the real part first and then the imaginary part. So we would say that the real part is 7 and the imaginary part is negative 7i. You would also just want to make sure that your answer, if during all your work ended up as negative 7i plus 7, you would want to make sure you reverse that order right before you end the problem. Okay? Turn to the next slide, and I'm going to do some of the multiplication examples with you.